Yeah.
I got a question here.
Yeah, go ahead. It's a good question.
I can't solve this equation the star A. So the original question, equation is this, and I just split them into two parts. And the first part is this term larger than or equal to the second one. And the answer give me is this. And the second part is the backwards.
Yeah. So this one, yeah.
And there is no overlap, so
There's no overlap.
and basically
But
there's
this-
no. And the answer
What are you talking about? Isn't there? This is between -12 and 2.
Yeah.
That overlaps this one, no?
No, it belongs to the natural number.
Oh yeah. So there's no overlap then. So I think the answer is no answer.
Give the answer the 1 and 2.
1 and 2.
I double checked my process and I think there is no mistake between the calculations, so I'm not sure where did I go wrong.
I'll have to check that for you later. I'm sure there's some small mistake. I'm sure.
Either mine or the book.
Yeah. I don't know. I'll have to check it later.
Okay.
Which one is it? 5A?
Star A.
Oh yeah. We'll see. Okay, guys, we'll continue now. Listen, we're continuing. No. Guys, we're continuing. Listen. Waiting. Ready? Yes. Okay. So the good news is the next lesson isn't as difficult because we finished the algebra chapter. So we're starting on the sequence and series chapter. So at the beginning of the chapter, not so difficult. So we're going to have a look at Pascal's triangle. You know this triangle? You've seen it before, maybe? So anyway, let's get started. So Pascal's triangle comes up with problems like this, where we want to calculate something like x plus y power n, and we want to expand it. So just to help us out, let's have a look at what's happening here. Okay, if you wanted to do power 0, that's no problem, because that's always 1. And also, power 1 is x plus y, so that's fine. Now, x plus y squared, you can think of that as x plus y times x plus y, which will be x squared plus 2xy plus y squared, and that's fine. Now, it starts getting a little bit harder after that. So, if you have x plus y cubed, it would be x plus y, yeah. And you can kind of see, well, we see where this is going. So, if I was to multiply this out, how many multiplications would that be if you think about it? So, what would you have to do? You'd have to do first with first, first with second, second with first, and second with second. So that's 4 multiplications. And when you multiply this, it'll make a quadratic, which will have 3 terms. Then each of those 3 terms have to multiply these 2. So that's 6. So you'd have 10 multiplications to do in total. And after you do the 10 multiplications, you would end up with this. X cubed plus 3x squared y plus 3xy squared plus y cubed. That's with 10 multiplications. And then the next one I think has 20 multiplications. Power 4. And so on. So we need to try and figure out, is there a better way to do this? And there is. So let me just draw something for you to help. Okay. Can I scroll down? Yeah. Okay, so let me just write this out. X plus y power 0 power 1, power 2, power 3, and we'll do power 4 if I have space. So this one here would be just 1. And then this one here would be 1x and 1y. And then this one here would be 1x squared, 2xy. The heck? Sorry, I wanted 2xy plus 1y squared. If we cube this one out, we'd get 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. Okay, if we were to do the next one, we would end up getting 1x4 plus 4. Hang on, I'm messing up my colours. Plus 4x cubed y. No, not yet. Plus 6 x squared y squared plus 4xy cubed. Finally,
plus 1y squared.
y4. Okay. Now, what I'm going to do is I'm going to take all those coefficients and just write them out separately. So I'll just write them out like this: 1, 1, 1, 1, 2, 1, 1. Make this a bit neater. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So you can see there's a pattern here that's emerging with the coefficients. For those of you who've seen it before, you'll notice that the number underneath the sum of the two above. So how did I get the 3? Well, that was because it was 1 plus 2. How did I get the 4 here? Well, that was the 3 and the 1 above it. Or how did I get the 6 here? The 3 and the 3 above it.
And always 1 at the end.
And always 1s at the ends, yeah, as like a boundary. So, let's see. So, for example, if I want the 4 here, okay, you can think like this. Mother, father, together, child. A number family tree, okay? Not difficult. This triangle is called Pascal's triangle. And it's a very, very useful triangle for expanding. Now I'll show you how to use the triangle in a moment, but what I need you to do is to write down the triangle. So let's make the triangle a little bit bigger. We'll see how many we can get added in here. So let's see, we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. One more. No, stop there. Okay. So, as you pointed out, you notice that it always starts and ends with a 1. That's one thing we notice about it. So, notice the 1s on the ends. That's one thing to notice. Second thing you can notice about it? Yeah, what about it?
The Bauer minus 1?
Huh?
Use the Bauer by 1?
What do you mean?
It was
Yeah. Well, that's the other thing that stands out, is that it's symmetric. You know, it's the same on the left and the right. You see here, you have like 1, 5, 10 and 10, 5, 1. You have this mirror image. Anything else you notice about it?
the next number is the sum of the two numbers above.
No, something about the pattern after you know that rule. So, here's something else that you mightn't have seen before. But if you look at the top row, the total is 1. The next row, the total is 2. What's the total here? 4. And the total here? 8, isn't it? And this one, so, yeah, the row total is a 2 power. And just to be clear, we call this first one row 0, row 1, row 2, row 3, row 4, row 5. And the reason for that is because we can say this total is 2 0, 2 1, 2 2, and 2 3, and 2 4, and this one is 2 5. And another reason we start counting at 0 is because, for example, this row here is for which power did we expand to get that one?
3.
It was cube, wasn't it? So it seems right to call this row 3. And you'll also notice one last thing, that the second number is always the row number. So row 5, the second number is 5. Row 6, I know it will start with a 1 and the next number will have to be, and because it's symmetric, I know it will finish with a 6 and a 1. Okay, so there's actually quite a lot of pattern, or a lot of things you can notice. And that's only half of it. There's there's other stuff too about this Pascal's triangle as well, but that's just enough for right now. So what I want to show you is how to use the triangle to expand something. Okay. Can I scroll down? Yeah. Okay. Right. So let's say I have something like I don't know. Let's say something like 2x plus 3y, and I want to cube this. Well, this is what you do. So watch carefully. You go to Pascal's triangle. Which row do we go to? Row number 3. Yeah. And you write down the numbers on Pascal's third row, which would be 1, 3, 3, and then 1. Bracket, bracket. And the reason I have 2 brackets with each number is because the next thing you do is you fill in each bracket with what's in the original. So the first bracket gets a 2x. And then the second bracket gets a 3y. Yeah, now we have to deal with the powers next. So, how do the powers work, if anybody knows this one? Yes. Well, like, what would be a rule for the powers?
Decrease by 1.
Yeah, decrease and increase by 1. So, you can actually start at 3 or 0. Doesn't matter. So, for example, if I start the x at 3 here, then the next x has to be 2, 1, and 0. And if the x started at 3, y has to start at 0, because they must be opposites for this trick. 0, 1, 2, and 3. Now you can swap those. That's fine. You can swap them. So you could have 0, 3, 1, 2, 2, 1, and 3, 0. It's fine. You get the same answer. Okay. So now let's clean this up. 2 cubed is 8. 3 power 0 is 1. 8 by 1 by 1. 8. And what's my x power? Cubed. And my y is a 0. So it's a 1. So I won't write it. Okay. 2 squared. And 3 power 1. 3. 4 by 3 is 12. By 3, 36. My x power, square, and my y power, 1. Okay, 2 power 1 is 2. 3 squared is 9. 9 by 2 is 18. 18 by 3 is 57. 57x, what power? Yeah, 1, and then it's y squared. Okay, 2 power 0 is 1. 3 cubed is 27. 27 by 1 by 1. 27. Any x's?
No.
Y cubed. Yeah. Now I'll do another one, but before I do it, I'll just give you a try. Give you a moment to try it. So let's make it a little bit similar. Let's say 3x minus 2y power 4. 6. Yeah, okay, no, 4. Try that. Yeah, now I'm not telling you because I want to see what you try to do to deal with the minus. Okay. Let's have a look at this one now. So if we can all look up, please. So I need to look at my fourth row. So I think I remember this correctly. Is the fourth row 14641? Yeah, 14641. Yeah. So as some of you were wondering, how do we deal with the minus? One way to deal with the minus is like this. I change this into 3. I think about it as 3 plus negative 2y power 4. Yeah, so you think about the minus 2y as a thing and the 3x as the other thing. So what goes in the brackets here, this one, 3x and minus 2y. 3x minus 2y, 3x minus 2y, 3x minus 2y, 3x minus 2y. The signs will end up alternating, yeah. But don't do it that way. Don't. Did you start off by filling in the numbers and alternating the signs? No. Oh, good, okay. The signs will alternate. Now, let's start with 4, and this power? 0. Next? 3, 1, 2, 2, 1, 3, 0, 4. Right, 3 power 4 is 81. Minus 2 power 0 is 1. 1 by 81 by 1? 81x4. 3 cubed is 27. Minus 2 power 1 is minus 2 by minus 2 by 27 is minus 54, isn't it? Minus 54 by 4 is minus 106, minus 216? 216x cubed y. 3 squared is 9, minus 2 squared is 4, 9 by 4 is 36. 36 by 6, now hang on, 36 by 6. 216 with a plus. And what do I have next?
X squared.
X squared y squared. 3 power 1 is 3, minus 2 cubed is 8, minus 8. Minus 8 by 3 is minus 24. Times 4 is minus 96. Xy cubed. 3 power 0 is 1, minus 2 power 4 is 16 by 1 is 16. No x's, y power 4. Yeah. Okay. So they're not, I mean, they're not that hard to do. It's just a bit of a pain to do, but it's nice enough, isn't it? It's relaxing. Yeah, sure. You've achieved something at the end. Yeah. This would be like a section A question in the exam, you know, for like four or 5 marks. Really, when you look at it, actually, how much have you written down? You've only actually written down 2 lines, you know, because the first one, yeah, it doesn't seem like it though. The first one is the question. The second one is your workings. So this is the first line of work, and then the last line, the second line of your work is the answer. Okay, so you're actually only writing down 2 lines. If the time is taken up because you first have to write down the coefficients, 1, 4, 6, 4, 1. Then you put in your numbers, so 3, 2, 3, 2, 3, 2, 3, 2, 3, 2, and then you put in the powers, 4, 0, 3, 1, 2, 2, 1, 3, 0, 4. Okay, and then you have to calculate to get the simpler form. But it's not so different each time. Yeah, what I want you to try now, we'll make it a little bit different. All of question 4. Just do question 4. Yeah, fun, huh?
Oh.
No, just do all of 4. All of 4. Huh? Yeah? Do all of question 4. Well, if you know what you need to do, tell me what you need to do then. You seem like a smart guy. What do you think you need to do then? Correct. One sec, let me just save this.